Here we have lesson 17.2, reflections. This is our second type of rigid motion out of the 3 that we're going to be doing this module. Remember that rigid motion is something that, or a transformation that's going to preserve our distances and our angle measures. So what you'll see on some of these pages is some paper folding to show how reflections work visually. And in class, I'm going to show you using a transparency, but in the video, just in the video, I'll show you more mathematical way to come up with this, with the reflection. On page 844 is some vocabulary. Perpendicular lines, we talked about that when we did the constructions in class. And it just means that 2 lines or 2 segments or whatever figures we're using are going to create right angles. And perpendicular bisectors, if you remember from when we did constructions, I had you construct a perpendicular bisector when we were looking for a midpoint. So a perpendicular bisector does 2 things. It makes a line that's perpendicular to it, and it also cuts it in half. The point where they intersect, right there, if you want to note that, ends up being our midpoint. So just remember, when a segment is bisected, that point where they touch is the midpoint of that segment. And finally, a reflection, just kind of bringing these ideas together, is we have this line right here, line L, is what we call the line of reflection. You can think of the line of reflection as like a mirror. So if I'm reflecting something from one side of the mirror, one side of the line, its reflection will be on the other side of it all the time. So you can see here, if I take point P, and point P could be my pre-image, or it is my pre-image in this diagram. P prime is the image. Then its reflection, or the result of the reflection, is so that the distance from P to our mirror, right here, to our line, is the same distance as the image, P prime, to the same line, right? So the same distance. Think of looking at yourself in the mirror. If you stare at yourself in the mirror, if you step away, it looks like your reflection also steps further away. So it's preserving the distance away from the mirror. If you walk closer to your mirror, your reflection will also come closer to the mirror, that sort of thing. Let's do a reflection on page 845. You got a couple examples here. I'm going to do number 6. I'll ask you to do number 5. So here's a mathematical way, and again, in class I will show you using a transparency. But we have our line of reflection right here. That's given to us, which means all the points, we can just do one point at a time. Here's point A. We're going to reflect it on the other side, over here, of our line. B, we're going to reflect it on the other side, so it'll be around here. And C is on the right side of this line, so we'll reflect it on the other side. So here's one way to do it. All right, if you come up with another way, go ahead and do it that way. But I'm going to come up with a slope for our line of reflection. So here's a bit of a review. To do slope, we do rise over run. So I pick a point, like a nice point that's on the line, and another one, like so. And I just figure out rise and run. So I can go from my bottom point, I go up 3 and right 1, which means our slope is 3 over 1. I'm going to go and erase that because I'll need that space to do our reflection. And if you haven't learned this before, it might be new. Lines that are perpendicular, they actually are related in slope. They're not the same slope. They end up being the opposite. So this one is a positive slope. So a line that's perpendicular to this one will be negative. So just take the opposite sign. And it'll also be the reciprocal. And the reciprocal means that we're going to flip it. So it's going to be negative 1 over 3. Okay, so all I did was take 3/1, right? Rise 3, run 1. I flipped it, and then I changed the sign. This is positive, this is negative. So what I'm going to do is I'm going to apply this new slope of negative 1/3 to our points. So from point A, negative 1/3 means I'm going to go down 1, right 3. So go down 1, right 3. And look where I end up. Just right on the line. That helps me figure out how far this thing is away from the line. So it's that far, right? You don't have to draw this line. But that's the distance, all right? The length of from A to our line, and it also happens to be perpendicular. Let me use a different color here. But it's also perpendicular, so we got a 90-degree angle. And if I continue from that line, I go down 1 and right 3 again from the line. That's my A prime because this is the same distance that I just went on the other side. And it's also perpendicular. If I do the same thing with B, go down 1, right 3. All right, there's our length from B to our line of reflection, and then I do the same thing, and there's B prime. Okay, what's nice about this is that when I use a slope, I always end up at the line of reflection. There are times when that doesn't happen, and so you have to, try your best to still get the same distance to your line of reflection, and then do the same distance on the other side. This one's just challenging because our line of reflection is kind of slanted. And if I do the same thing with C, except with C, I have to go backwards, right? I can't go down 1 and right 3. I'm going to go up 1 and left 3. And again, happen to be at the line of reflection when I do that. So let's continue up 1, left 3, and there's my C prime. So this distance and this distance are the same. Choose a different color. If I connect A prime to B, C prime to B prime, there's my image, the blue triangle. So the red lines you don't have to draw. It just shows that A and A prime are the same distance to our line. It shows that B and B prime are the same distance to the line of reflection, and the same thing with C and C prime. Not necessary to draw, but it helps you see that. All right, make sure that you are drawing the image, right? The points A prime, B prime, C prime. Make sure you are labeling those. So go ahead and try number 5 before you see the answer. On the next page, 846 at the top. This isn't something I would expect you to really memorize. It's good to memorize though. Here are the rules, coordinate rules for different reflections. So when we reflect, we have to know which line we're reflecting over. Last year, you may have only learned the first 2. So reflecting across the x-axis, reflecting across the y-axis. You still need to know how to do those. There will be some problems like those in your assignment. Here's the coordinate rule if you're reflecting over one of the axes. What we're adding this year, you didn't do last year, is we're going to be reflecting over different lines. And so you'll need to know how to graph these lines or what they look like. So the line y equals x is the most basic linear equation. It's the equation where x and y are the same numbers. So points 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, and so on. And then you just connect that line. The line y equals negative x is where x is the opposite of y. So whatever x is, you change the sign, right? Or make it negative. So if x is 1, that's negative 1. If x is 2, that's negative 2. If x is 3, that's negative 3, and so on. And you connect that to make a line. So anyway, those are the rules if you were to reflect over those lines. So let's look at some examples. On the next page, number 9, number 10. I'll do number 9. Actually, I'll start you off with both of these, but I won't complete them all the way. I'll actually just kind of get you started with, I'll do one of the points possibly, and then we'll reflect it over the line that's given to us. So number 9, we have 4 points. So I expect you to know how to, of course, plot all those points. Make sure you label them. I'm only going to draw one of the points. So let's do the first one. 3, 4 is up here. point S. And we're going to reflect it across, it says the x-axis. Well, here's the x-axis. That's going to act as our line of reflection. So I'm going to put L-O-R, line of reflection. We want to reflect S all the way across. What's nice about doing over the x and y axis is that we just have to count. We don't really have to find any slopes or anything because we know that we just need to go up and down since our line of reflection is just going left and right, because that's going to be perpendicular if we go up and down. So this distance right here is just a distance of 4, which means on the other side, if I go a distance of 4, there's my reflection. And so you just do the same thing with all the points. Okay, so that's review of last year. Number 10 is going to be a little bit more challenging. Well, let's do one of the points, -4, -2. Here's point A. And this time we're going to reflect it across this line, y equals -x. Remember that whatever x is, y is the opposite, except for 0. If x is 0, y is 0, right? You can just plug it in. I said that if x is 1, y is -1. If x is 2, y is -2. If x is -2, y is +2. That sort of thing. So whatever x is, y is just the opposite of that. So if you were to actually graph those points, we get a line that looks like, I made a mistake, I just realized. That should be -2 there. But we get a line that looks like this. And that is a slope of -1. You want to write that down? Or -1 over 1. Which means going this way, the slope is going to be a +1. Which is the same as 1 over 1. So if I take point A and I go up 1 over 1, up 1 over 1, and up 1 over 1, I end up here. And you look at how far that distance is, and we want to copy that distance on the other side. So I did that 3 times, looks like. Which means my point A prime will be right there. And you do the same thing with all of the other points. So again, the goal when we're doing reflections and we have our line of reflection is just to figure out how far away the points are to our line and then trying to copy that. On page 848, you have number 12 and 13. This time, they give us the pre-image and the image, and we are asked to draw the line of reflection, come up with that line of reflection. So here is one way to do it. If you have another way, that's totally fine. But I'm going to connect B and B prime. I'm going to connect A and A prime, C and C prime. I highly recommend you use a straight edge when you're doing that, unless you can draw pretty straight lines, because we want to be accurate here. And if you remember the properties of when we have our line of reflection, B and B prime, or a pre-image and its image, will always be the same distance. So the same distance to the line, which means we want to find the midpoint. The line of reflection always goes through the midpoint. And you can do this by observation. Okay, so I can see that my midpoint for B and B prime is right there, where that blue dot is. The midpoint for A and A prime, I can figure out it's right there. All right, so it just cut your segments in half that are connecting your pre-image and your image. Midpoint of C and C prime is right there. And your line of reflection just goes through all those points. That's all it is. Not really much mathematical thinking here other than just to observe where your midpoint is. And that's our line of reflection. Now you may be asked to come up with that equation. That's something that we have done in the past. So don't be surprised to see something like that on your assignment, if that's the case. Try number 13. You'll see the solution up here very, very shortly. But try that out and we'll be done with this lesson.